Welcome to my channel, Kuda Edutainment TV. Please follow, like and subscribe to my channel. I want to reach 1000 subscribers by the end of September, so please help me to achieve this goal by sharing this link, also subscribing, sharing to your colleagues, those who are at universities, those who are at high schools and so forth. Please help me do that. Alright, so today we are going to be dealing with binary manipulation. So binary manipulation, we can add binary numbers, we can subtract binary numbers, we can multiply binary numbers. But for the purpose of the computer science IGCSE syllabus that I'm making this video series on, we are only going to be dealing with binary addition. So there are simple rules that you are supposed to follow when doing this. The first rule being 0 plus 0, it will give us 0. And then 0 plus 1, it will give us 1. 1 plus 1, it will give us 0, carry 1. And 1 plus 1 plus 1, 3 ones. If we add 3 ones, they will give us 1, carry 1. So you will understand this when we'll be demonstrating why do we say 0, carry 1, why do we say 1, carry 1. So this is what we are going to be dealing with today. So on this channel, my focus is to provide content to anything that has to do with ICT. As you know, computer science is part of ICT, but on the IGCSE syllabus, we've got computer science as a separate subject and also ICT as a separate subject. So if you need videos on ICT, IGCSE, as well up to A level, you can as well make a request, right? You can make a request on the comments below, then I'll do the videos for you. So please like, share, subscribe and comment. Alright, so these are the rules I was talking about, the 4 rules. The first rule, it says 0 plus 0 is equal to 0. Second rule, 0 plus 1 is equal to 1. The third rule, 1 plus 1 is equal to 0, carry 1. 1 plus 1 plus 1, 1, carry 1. So now we've got a question which says add the following binary numbers. So these are the two binary numbers we are adding, 1, 1, 1, 0, 1, 0 and 0, 0, 1, 0. So using the rules, 0 plus 0 is equal to 0, 1 plus 1 is equal to 0, carry 1. 1 plus 0 is just 1, 1 plus 0 is 1. So you can prove whether this answer is correct or not. So the only way we can prove if this answer is correct or not is by converting these binary numbers we are adding together into their decimal equivalents. Then that answer, right, we compare the answer we get and the conversion of this binary answer, right? So let me quickly show you how do we do that. So this is the proof. So 1, 1, so it's 1, 0, 1, 0 to D9 is equal to, so the binary units, 4 big binary units are 8, 4, 2 and 1. So the binary units what you are switched to on in this case are 8 and 2. So 8 plus 2, it will give us 10. And for the second one here we have got 0, 0, 1, 0, meaning to say only binary unit 2 is switched on. So this is 2. So 10 plus 2, it will give us 12. So if we convert this binary number, it should give us the same number as this one. So the binary units that we have, 8, 4, 2 and 1. So if we add the binary units which are switched on, which is 8 and 4, we will get 12, meaning to say our answer is correct. So this is how we go about adding binary numbers. So next I'm going to demonstrate how to convert, in fact, how to add binary numbers which will give us an answer which has got more bits as compared to the binary numbers we are adding. So this is what I'm going to demonstrate to you next. So our next question is for us to add these two binary numbers, which is 1, 1, 1, 1 and 1, 0, 1, 1, right? So we use the same rules that I've already given you. So 1 plus 1, 0, carry 1. And when you are adding 3 ones, it's 1, carry 1. Now we have 2 ones. 1 plus 1 plus 0, it's 0, carry 1, right? 3 ones, it's 1, carry 1. 1 plus 0, it's 1. So what do we do now? Because the numbers that we are adding, they were 4-bit binary numbers, but our answer is now a 5-bit binary number. So what we simply do, the last bit here, we simply circle it and label it as overflow. So this becomes an overflow bit. An overflow bit. In some instances, you can simply throw away the overflow bit and remain with these two, but I would encourage you not to throw away this overflow bit. Rather, you simply circle it and then label overflow bit. Why? Because if you throw it away, the moment you try to prove whether your workings are correct or not, you will see that the answer will not be equal to the denary value of adding these two binary numbers. Let me show you. So let us convert 1 to denary. So this one, if we convert it to denary, it will simply give us 15, because this is 8, 4, 2, and 1. 8 plus 4, right? 8, 4, 2, and 1. So 8 plus 4 is 12. 12 plus 2 is 14 plus 1, 15. So 15, and then here we have 8 plus 2, which is 10 plus 1, 11. So if we do 15 plus 11, it will give us 26. And we convert, if we convert 1010 to denary, it won't give us 26, because this will be 8 plus 2, which is 12, right? But if we leave this overflow bit clearly circled and labeled, then our answer would be correct, because if we convert this 5-bit binary number to denary, it will give us 26. Let us do that together. So 11010 to denary or decimal. It's called denary or decimal. So 2 to the power 0 is 1, 2 to the power 1 is 2, 2 to the power 2 is 4, 2 to the power 3 is 8, and then 2 to the power 4 is 16. So the binary units which are switched on in this case are 16 plus 8 plus 2. So 16 plus 8, it gives us 24, and then 24 plus 2, it will give us 26. So this is how we manipulate, this is how we add binary numbers. So yeah, that's all. If you've got any questions, you can raise them in the comments below so that I can attend to those questions for you to understand. That was the lesson for today, binary number manipulations. So just in summary, you simply have to know these simple 4 rules for you to be able to add binary numbers. 0 plus 0 being equal to 0, 0 plus 1 being equal to 1, 1 plus 1 being equal to 0 carry 1, and then 1 plus 1 plus 1 being equal to 1 carry 1. So once you know these rules, you won't have any problems in adding binary numbers. So like the examples that I gave you, there are some instances where you can have the answer with a greater number of bits as compared to the binary numbers that you are adding. So what you simply have to do, you simply have to clearly label, right, that extra or those extra bits as overflow bits or overflow bit. So in some instances, some scientists, they will encourage you to throw them away. In some tutorials, they say you can throw the overflow bit away, but it can be difficult if you want to prove, right? When you want to prove whether your workings are correct, it will be difficult. Why? Because the remaining bits will not give you the actual denary number that we will get after adding those binary numbers as denary numbers. So that's my take on binary manipulation. So in the next video, we are going to be dealing with negative number representation. So all along, we've been dealing with positive numbers, how to convert positive denary numbers or positive decimal numbers into binary numbers. But in our next video, we are going to be dealing with how to represent negative numbers, because they can as well be represented in this binary. So that's what you're going to be focusing on the next video. So please subscribe to my YouTube channel, share the link, comment, like. My aim is to reach 1,000 subscribers at the end of September. So please help me achieve that goal by sharing my videos, subscribing to it, to your colleagues, right, at high schools, in colleges, in universities. Because some of these concepts, they apply at high school level, they also apply at college level, they also apply at university level. So you really need to share this video. All right. Thank you very much. See you in the next video.